thanks for watching, and today let's practice a bit with the Fourier transform and solve AUT plus BUX plus CU equals 0 with some initial condition f of x, where here A is non-zero, otherwise the PDE would be a bit boring. Now, for this, we first need to apply Fourier transforms on both sides. So, in other words, put hats on both sides. So take the Fourier transform and I would just like to remind you which definition I'm using. So u hat kappa t is the integral from minus infinity to infinity of u of xt ei kappa x dx. And so if we put hats on all sides, what we end up getting is a ut hat plus b ux hat plus cu hat is 0 hat, which is just 0. And now, I would like to remind you of a couple of useful facts about the Fourier transform. First of all, because this t is constant with respect to x, and we're taking Fourier transforms with x, ut hat is just d over dt, u hat. So in other words, we can pull the t derivatives out here. But on the other hand, we do have a Fourier transform miracle, which says ux hat is minus I kappa and then u hat, which will simplify our PDE a lot. All right, so far we had a ut hat plus b ux hat plus c u hat is 0 hat, which is just 0. And now applying the formula here, we get a d over dt u hat plus b and then minus I kappa u hat plus c u hat is 0. And what's nice about this becomes a simple ODE in u hat. So a d over dt u hat then becomes, so putting it on the other side, bi kappa minus c u hat. And remember, a is non-zero, and so we get d over dt u hat is bi kappa minus c over a u hat. So that's very good. We now got an ODE in u hat, which now we can solve. So the next step is to solve the ODE. So step 2, solve d over dt, maybe here, of u hat is bi kappa minus c over a u hat. But notice this is of the form y prime equals ay. So the ODE from lecture 1 of the ODE course, whose solution is y of t is ce to the at. And so in particular, u hat kappa t is constant. So constant with respect to t, and therefore a function of kappa. And then A is this huge thing here. So bi kappa minus c over a, and then times t. And that's it. Okay. So e to the whatever constant we have times t. Now, we can actually be more explicit and solve for c kappa, because if you let t equal 0, then u hat kappa 0 is c kappa e to the bi kappa minus c over a times 0, which simplifies to c kappa. And then what we end up getting is C kappa is U hat kappa 0. But if you use the definition of the Fourier transform here, the definition of U hat, then you'll see it's just the Fourier transform of the initial condition. So it's the same thing as F hat of kappa. Which is good, because now we actually have a super explicit definition of U hat. Okay, so just to remind you, what have we found so far? We found that U hat is constant, but here the constant is F hat times this exponential term. And the whole point in our Fourier transform extravaganza is to write the right-hand side as a hat. Because then U will be what mystery function is under the hat. And in fact, let's do that now. So step 4, I think, 3 or 4. So U hat kappa T. Now, for reasons that'll be apparent in a second, let's split this up into two terms. So E of minus C over AT and E of, I believe, B over AT, T kappa I, and then F hat of kappa. And the reason we're doing this is because we want to use what's called the shifting property of the Fourier transform. So recall, so if you take a function f and shift it by a units and take the Fourier transform, an extra exponential term comes out. So E of a kappa I comes out of the Fourier transform. So F hat of kappa. And while you can also read this in reverse, in other words, if you have some exponential term, a kappa I of the Fourier transform, and you put it in, it just shifts the function. X minus a hat. And in fact, this is precisely what is happening here. So what will happen is this will shift the function. So you have kappa T is E of minus C over AT. And now F, in this case, of X minus B over AT hat. And last but not least, well, this term doesn't depend on X or kappa at all. So this is just the Fourier transform of E of minus C over AT and an F of X minus B over AT hat. And then the good thing is we're finally done because we found U hat and wrote this as a hat. And so in the end, we can just remove the hats. So I want to remind you, U hat is this mystery function hat. And so U of xt now becomes E of minus C over AT and an F of X minus B over AT. And the cool thing is, if you plug in t equals 0, you'll see that at least the initial condition will be satisfied. Alright, I hope you like this. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.